Okay, in your packet, after what we covered the other day, we've got a function family review we're going to go through real quick here. Let's start with the first one. We want to look at what is the function family name given. What would the graph look like if we could come up with the equation over here? So let's come up with an equation of just a standard quadratic. Let's not make it too crazy. Let's just go with the basic one. That's fine. We know we could add on to the x to shift it left and right. We could change the a value in front of x. And we could add all over here to go up and down. We can understand all that stuff. But just as long as you know that a quadratic is squared, that the result should be a parabola. So let's keep track of our inputs and outputs over there. The axis of symmetry is going to be the y-axis because we haven't done anything to this, so it's just going to be centered on the y. So you can plug in 0, 1, and 2, and then -1, -2, and just see the symmetry going on there. When you plug in 0, obviously you get 0. You plug in 1, 1 squared is 1. And when you plug a number in with a negative, make sure you plug in with parentheses. So if you were to do that here, it'd be y equals, -1 squared, and that's still +1, hence the symmetry, -1, 1. You plug in 2, 2 squared is 4, and then -2 with the parenthesis squared is +4. So 2, 4, and -2, 4. And then you play the game where you try to draw your best parabola without screwing up too much. Let's put some arrows on the end because it is continuous in both directions. Okay, moving on. This is the one we should be very familiar with and know how to do precisely. It's linear because it makes a line. And what's the slope? Let's see, it looks like we got up 2 over 1, 2, 3, up 2 over 3. So y equals 2/3 x. And then the y-intercept is at -2. Should not miss that one. Ooh, this one. Now, I will say I gave this review to my algebra group last year, and this was the one that was most commonly missed. For whatever reason, I didn't do well with the inputs and outputs, and I didn't know it was continuous in both directions. So let's start over here. Actually, let's start there. What kind of function do we have? Well, if x is the exponent, it's exponential. Go ahead and jot that down. Now I need to locate this thing on the grid. I do notice there's a -2 right here. There's also a -2 on the linear, which moved it down 2 units on the y-axis. What it's going to do for the exponential is that's the number it cannot drop below. So if you want to go ahead and put a dashed line at -2, we've essentially just lowered the curve, and so it'll be approaching -2 as x gets exceedingly negative. Okay, so going in this direction. Obviously, it's exponential increase over here because this value here is positive. So we just got to locate it. Let's do some inputs and outputs. So it's good to start with 0 and see where we're at. So if you plug in 0, 2 to the 0 power is 1, and then 1 minus 2 is -1. So 0, -1 is right there. Let's go ahead and plug in 1 and 2 and just get an idea as we head that direction. So 1 goes in, that's 2 to the first power, minus 2, that's 2 minus 2, 0. 1, 0. Plug in 2, 2 squared is 4, 4 minus 2 is 2, so 2, 2. What we have from there is an exponential increase. Notice that that interval is faster than the one that preceded it, and this one will be faster still. You'll plug in 3, 2 to the third will be 8, 8 minus 2 will be 6, so you'll be at 3, 6, which is already off the grid, up there somewhere. But what I noticed last year is a lot of my students were just stopping here, and they're like, okay, I'm good, and I'm just going to shoot up that way. But you have to remember to go back and see where it's approaching. We already determined it's going to approach -2. So let's confirm that by plugging in just a few numbers and know how to handle your negative exponents, because it's also in a video last week.
I hereby banish inputs and outputs from my kingdom. Da 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 da.
So you plug in -1. I'll go up here and do that. 2 to the negative first power is reciprocal. It's a fraction. That is 1 over 2 to the first, or 1/2. What you have here is 1/2 minus 2, which is -1.5 or -1.5. Okay. If you plug in -2, you have 2 to the -2 minus 2. So that is 1/4. Okay. 1/4 minus 2 is negative 1 3/4, or negative 1.75. So what we're doing is we're trending back towards this dashed line that we put in there, getting negative 1 3/4, and then we'll get closer and closer, but we will never touch it. Okay? Might use a little highlighter this time just to show you. No touchy, no touchy, no touchy, no touchy. It's exponential increase. Yeah. That's cool. Last one's radical, bro. There we go. Get out of the way. Radical. So we know it's radical. We don't have a graph yet because we have not come up with a function that is radical. So let's do y equals the square root of something. And just to make it a little spicy, let's throw in there at x, I don't know, we'll go plus 2. Ooh, now I'm happy. X plus 2. So if we're going to do a xy input-output chart that has been banished from the kingdom, we would plug in, well, there's only you're limited in your domain. I mean, the domain's infinite, but you cannot plug in numbers that will create a negative underneath the radical, which would be imaginary. So you can't plug in negative 3, because negative 3 plus 2 would be negative 1, and the square root of negative 1 is imaginary. So the first number you're allowed to plug in is negative 2. And then negative 2 plus 2 is 0, and the square root of 0 is okay. So negative 2, 0 is where we exist, if you want to call that the beginning. And then we can go with negative 1. That's totally fine, because negative 1 plus 2 is 1, and the square root of 1 is 1. So negative 1, 1. Okay, here we go. Now we want to be kind of wise to this as to what we want to plug in. If you plug in 0, 0 plus 2 is 2, and radical 2 is crazy, so probably not the best thing to graph. So we'll skip over 0, skip over 1, and we'll go straight to 2, because 2 plus 2 is 4, and the square root of 4 is 2. So we plugged in 2, and we got 2. Now, I don't know if we're going to land on this grid anymore. We can take a look, but 3, 4, 5, 6, 7. You'd have to go all the way to 7. And then 7 plus 2 is 9. Radical 9 is 3. I know it's plus or minus 3, but we're going with the positive root right now. Okay. So it's 3. And 7's off the grid, and it'd be over here somewhere. So how about we just call it a day for our radical. I missed that point right there. I did my best, though. And I used highlighter again, so I should probably go back and highlight those, make it more fun. Boom. So we just went over 4 function families, and then there's another page here where it would be nice if you could fill some of this out on your own, and then we could talk about it in class. That'd be kind of cool if you have time to do so, and your brain is, with it. So how about you try this one? Can you create an equation that is continuous, is an absolute value, and has a maximum at 0, 3? Ooh, bit of a challenge there. See how you do. Can you describe the difference between continuous and discrete? We did talk about it in the Zoom. If you have forgotten, you could Google it and then write it down there. And then let's try a linear piecewise, because you need to. John and Josh decide they're going to go on a road trip. And it looks like there's 3 phases here. For the first 2 hours, they go at 65 miles per hour. They have a pit stop for a half hour, and after they get gas, they go on the interstate at 65 miles per hour again for 3 hours, and they arrive at their destination. So 3 phases. Can you graph all 3, come up with the equations, and the y-intercept of phase 3, which is the part where you actually have to calculate. Okay, that's it for today. So please try to finish this page if you can. And I don't know. I think I'm done. I am done.